Okay, this video is about transformations of the quadratic parent graph. And this is review from chapter 4. We learned all of this in chapter 4, and we're reviewing it now because we'd like you to be able to relate what you've learned when it came to quadratics and transformations to what we're concerned with now, which is cubics and transformations. So the next video is going to show you how to relate this to cubic functions. All right, so what you're looking at right now is the parent graph f of x equals x to the power of 2. And just to review, I'm going to pick 5 points for x and plug them in to find f of x, and just verify that they do lie on the parabola that you're looking at. So 0 to the power of 2 is 0, 1 to the power of 2 is 1, negative 1 to the power of 2 is 1, 2 to the power of 2 is 4, negative 2 to the power of 2 is 4. Let's plot those 5 points. So I have 0, 0, 1, 1, negative 1, 1, 2, 4, and the reflection of 2, 4 across the axis of symmetry is negative 2, 4. So here is f of x equals x squared. Its vertex is at the origin. All right, on the next slide, what we see is some rules about how adding A, C, and D to our graph, or to our equation, can change what the graph looks like. So here's the generic function for a quadratic, and depending on the values of A, C, or D, the graph changes either its shape or its position. So we're going to start with A. A can do a couple of different things to our graph. First of all, if A is negative, A will reflect the graph across the x-axis. And then, besides reflections, A can either stretch or compress the graph. So if A, the absolute value of A, is greater than 1, then A stretches vertically away from the x-axis. If the absolute value of A is less than 1, for example, 1/4, if the absolute value of A is smaller than 1, then the graph compresses vertically closer to the x-axis. C are for shifts or translations to either the left or the right. If C is positive, the graph moves left. If C is negative, the graph moves right. So C determines left or right. D, oops, I meant to do that in blue. D determines up or down. Okay, D, if D is positive, it goes up. If D is negative, it goes down. Positive up, negative down. Okay, and I gave all of this to you on the handout. Like I said, this should already be in your notes from when we studied quadratics in chapter 4. So you don't have to write it again, but this is reminding you of the rules. All right, so here's my first problem. What I want to do is I want to list the transformations of f of x equals 2x to the power of 2, and then graph that new function. Okay, so here what I've got is a value for A. Right? A is positive, that means it's not a reflection. And A, the absolute value of A, is greater than 1. That tells you that this is a vertical, let me spell this correctly, vertical stretch. I probably spelled that wrong too. It's a vertical stretch away from x-axis. And since this transformation is vertical, what that means is it's going to change the values of y. Okay, y is the vertical, x is the horizontal. So here what I'm going to do is I'm going to have the same values for x, but everything in the y column I'm going to multiply by 2. Okay? So 0 times 2 is 0, 1 times 2 is 2, 1 times 2 is 2, 4 times 2 is 8, 4 times 2 is 8. Okay? Since it's a vertical stretch, everything in the y column is multiplied by 2. Let's plot those points. 0, 0, 1, 2, and the reflection across the axis of symmetry is negative 1, 2. 2, 8, and the reflection of 2, 8 across the axis of symmetry is negative 2, 8. So here's my parabola in green. And my parabola in black was the parent function. So the green function is stretching away from the x-axis. It's getting taller and skinnier. Okay, our next problem has more than one transformation. It has an A, and it has a D. D is 3. I know that that is a D because it's not inside parentheses. If it were in parentheses, we'd call it a C. So I've got D is 3. That means it's going to shift up 3. And the 2 is going to be the same thing as it was in the graph before. It's a vertical stretch. Okay? So I've got, if I'm listing my transformations, I've got a vertical stretch, and I've got a translation up 3. Okay. All right, both vertical and the upward transformation, the upward translation, are both y, okay? Y is a vertical coordinate, up is a vertical motion. So again, that means that we're only going to change our y coordinate. Our x coordinates are going to stay the same. So again, I'm going to have 0, negative 1, 1, negative 2, 2. Those are all of the values that I used in my parent graph. But for my y now, I'm going to multiply by 2, and I'm going to add 3. I'm going to take whatever is in y, I'm going to multiply it by 2, and add 3. So 0 times 2 is 0 plus 3. 2 times 1 is 2 plus 3 is 5. The same thing for this one. 2 times 1 is 2 plus 3 is 5. 4 times 2 is 8 plus 3 is 11. And the same thing, 4 times 2 is 8 plus 3 is 11. Let's plot those points. Okay, so my vertex in the parent graph is at the origin. But my vertex in my transformation shifted up 3. It's a translation up 3. All right, I've got the point negative 1, 5. And its reflection across the axis of symmetry is positive 1, 5. I've got the point negative 2, 11. So off the graph a little bit. And the reflection across the axis of symmetry is positive 2, 11. So here is my transformed graph, and here was my parent graph. And again, there were 2 transformations. This is both a vertical stretch away from the x-axis and a translation up 3. One more problem. Okay, this graph has also got two different transformations. We've got a C and we have a D. So C moves either left or right. Since this is subtracting, it is a move to the right. So this is a translation to the right 4. And it is a translation 3 up. Okay? A is 1. All right? So there is no reflection, there is no stretch, there is no compress. Okay, so I had to go back a little bit. What I'm doing here is I'm going to make a new table, all right, where I'm going to, since I'm translating to the right 4, that's a vertical, that's a horizontal movement. So I'm adding 4 to my x column. And since I'm going up 3, I'm going to add 3 to my y column. So I've got 0 plus 4 is 4, negative 1 plus 4 is 3, 1 plus 4 is 5, negative 2 plus 4 is 2, and 2 plus 4 is 6. So because of my translation to the right, x is left and right, and that affects the x-coordinate. Because of my translation 3 up, I'm going to add 3 to everything in the y column for my parent graph. So 0 plus 3 is 3, 1 plus 3 is 4, 1 plus 3 is 4, 4 plus 3 is 7, and 4 plus 3 is 7. Okay? So again, this sign here, oops, I meant to do that in red. This sign here, that negative sign, is the opposite when it's inside those parentheses. That is a move right, and so therefore we add 4. Okay, let's plot those points. I've got 4, 3. 1, 2, 3, 4 to the right, 1, 2, 3. So the vertex moves to the right 4 and up 3. That's the vertex. Now we've got 3, 4. And its reflection across the axis of symmetry, which would be 5, 4. And we also have 2, 7. And its reflection across the axis of symmetry, which would be 6, 7. Okay, so here is my transformation of the parent graph. Here was the parent graph. This is what we call a rigid transformation. It did not change the shape because the value of a was 1. It only shifted it to the right 4 and up 3. Okay, that's it. Tomorrow we'll look at cubic transformations.